Hi there, this is exercise 7A.2. We're looking again at game theory and predominantly for the OCR board. I mean, it's interesting, I've just switched schools, and one of the things I've noticed is my new school is going to do EdXL, and already I've spotted differences. Same method, same, nominally the same topics, but subtle differences within those methods. So just be aware then that this is predominantly aimed at OCR, but there will be some, obviously some similarities with others as well. So this is one aspect of game theory and strategy, which I'll come on to, and it's all about drawing graphs and stuff. But we're going to start off with some other bits and bobs, and so here goes. So strategy. Here is a payoff matrix then. So we've seen these before. It's a zero-sum game, so we should by now understand what that means. And the question basically says, look, we've got player A, we've got player B. What should they play? That's what we're looking at. And in each case then, so if player A plays W, so let's just make sure we understand what's going on. So if player A, I don't know what kind of game it is, but they've got player A has got four options, and let's assume this player A chooses W. Now that basically then determines who wins based on what player B chooses. And you can see if player B chooses to play P, whatever option P is, then W will win 5 points. But if player B chooses Q, then Q actually, it turns out to be better for player B. Player A will lose 4 points. And if player B chooses R, then it's a draw, effectively. No points for either side. And what you'll notice is, whatever happens, we've got these given to us. And where these have come from doesn't really matter. But the idea, I suppose, is if W knows that player B is going to play, I don't know, Q, player A definitely wouldn't pick W. So if we knew they were playing here, we'd pick a different one. Which one would we pick? We'd probably pick that one, actually, that X. If we knew that player B was going to play P, which one would we? Well, player A would pick this one because 7's the highest number. But of course, you don't know what they're going to play. So I suppose we were talking now about how to maximize your chances of winning. And what the question says, it says, although player A never wins points by playing X. So if we look at X, he either gets -2, he gets 0, or he gets -1. Yeah, so he literally will never win. He'll either lose, or I suppose he'll draw on this middle one. Explain why this could still be a winning strategy. And I suppose it comes down to this one. It comes down to the fact that if he plays X and player B chooses to play Q at the same time, you can see that of the four options, 0 is actually player A's best option. So I suppose here I could write for part A, I could say if B, this is player B, plays, Q, then X gets the least bad result. I suppose would one way to say it, the least bad result. I'm not sure if there's a better way of saying that. Effectively, he doesn't lose. What about B? What does B ask me? B says, identify a strategy that player A should never choose. Now, this comes to an idea called dominance. Now, you often get one option which is always rubbish compared to another option. Let's just see if we can find it. So player A should never choose it. So it's definitely not W. W seems to be a good one. It gets 5 points. Then it's bad, but 5 is a pretty good. Oh, actually, hang on a bit. Y there, the 7 beats the 5. Is that the -2 beats the -4? I mean, he still loses 2 points, but that would be -4 points. And the one I thought it wasn't going to be, it turned out it was. So for B, I'm going to say Y always gets more points than W. Effectively, I suppose we're saying 7 is greater than 5. We're saying -2 is greater than -4. And the last one, 3 is greater than 0. It will always beat W. So we should never play W. All right, and now I know. Is there a strategy that B should never choose? So well, let's have a look. I mean, the way they're wording it, probably not, but perhaps there is. So is there one that always wins? So 5 beats -4. Now, bear in mind for player B, what you want to do, be aware of, is you these are what happens for player A. So player A would lose 5 points, player B would lose. So did I say that right? Player A would win 5 points, but player B would lose 5 points. We've seen this is also written in the box as 5, -5. With zero-sum games, you don't need to worry about that so much. But so I know that player B here will lose 5 points. He will win 4 points. It'll be a 0. So we just got to bear that in mind. So 5 is worse for player B. So we want negative numbers, really, is what I'm saying. So that is better. Naught. No, that's the wrong way around. So you'll feel like that one beats it, but that one beats it. So player B, P and Q are very similar, sort of in as much that they sort of alternate as to which one's better. What about here? Q wins, so this is the one that wins compared to R. And now this is the one that wins. This is the most negative. Player B will win 1 point from that. So Q and R doesn't make any difference. So I'm just going to compare P versus R now. R wins this one. The -1, this is the better one again. So I think no. P is not dominated by Q or R, and vice versa, I suppose. And Q likewise is not dominated by either. There's no dominance going on. Q likewise is not dominated by R, and vice versa. So what did I put? So I don't think there's any logic in that. So what was the answers? It says no, for example, P is better than Q when A plays X, but worse. So this is what I was going through. And I'll leave those scores up for a couple of seconds so you get a chance to read it and go back to it and get your head around it. But the idea basically was that in our example that we had, there was never one that was always better than the other. Sometimes it was better here, but sometimes it was better there, and that's not dominance. And so we're leading into this idea of what domination is. Sometimes a row or column is dominated by another. And from the textbook, this basically said this: if every entry in a row is greater than the corresponding entry in another row, then these rows are said to be dominated. If you look at columns, it says down here, it says similarly one column dominates another when the payoff for the player on columns is better in every row. Remember that in a zero-sum game, the player on columns wins the negative value. So you get the idea that you've got to be careful with pluses and minuses. Now, on that basis, what I did was, let me show you that properly actually. In the last example then, this was what we had. This is the payoff matrix. So what it means is, because player A should never ever play W. We've just seen that. We've said that Y dominates. We said Y is always better than W. Y dominates W. So what you can effectively do is wipe it out and just have now X, Y, Z. We've got rid of the W because there's no need for player A to ever play it. And that simplifies things. If you can spot a dominating row or dominating column, you can remove it, and it becomes a simpler question. Now, look, here's a dominance example then. So look at the payoff matrix, it says, and there we have it. This is very similar to the last one, actually. Find a column that is strictly dominated by another column. Well, we're looking for 1 being always bigger. Now, 6 always is bigger than 1. Now, bear in mind that means D is better than C because it's negatives and stuff. But basically, this is bigger than this. Now, -2 is not. -2 is smaller. So we've got C and D. There's nothing going on with C and D. I'm going to try and B and C now. I bet it's to do with A. I went to the last one. So 6 is bigger than that. -2 is bigger than that. But -3 is smaller than 0. So B and C aren't dominated. What about here? A and B. That is bigger than... Oh, look, I should have just done this initially. You see the way these... Now, remember, for the columns, player 2 here, that number -1 refers to player 1 losing a point. So in actual fact, player 2 here is going to gain a point here. Whereas here, they're going to lose 5 points. Here, they're going to win. So if you like, this one beats this one. And this one beats this one for player 2, remember. And this one gets no points, whereas this one would lose player 2 7 points. So actually, I think that A is dominated by B. Dominated by B. And what's it say? Find a row that is weakly dominated. Now, this is a shame. I didn't stress this word, but strictly dominated is just a term that basically says it's not just better than. It's not that better than or equal to. It's always better than. So this is different from weakly because these can be equal to. So I think in the rows, and on the basis I've got 2 5s here, I suspect it's here. So let's have a look at this. So I'm going to delete all that writing I had. There's my, get rid of all that. And I'll just now get my pen back, hopefully. Yeah, there it is. And I reckon, look, 5 is better than that. -1 is better than -3. So this is the better one. Now remember, we're doing it for in the rows. So player 1 scores. These are actually the scores. 6 is better than -2. Yes, it is. And 1 is better than -1. Yes, it is. So they all seem better, apart from this first one where they're equal. Now, what that basically means, it doesn't really matter that they're equal. It doesn't do you any harm from playing one rather than the other. So I'm going to say here that basically K always wins. So the way to say that is that L is dominated. You've got to be a bit careful of the wording here because you could easily say this the wrong way around, by K. Now I could, I suppose, say exactly the same thing, K dominates L. Now that's what I mean about the fact that you've got to be careful on your ordering. On the first one I could have said B is better, I suppose, than A, so B dominates A. You've just got to get your head round the ordering. Have I got answers coming up here? Let's have a look. No, I didn't have answers, so you're going to have to trust me on that one. So here's an option, another example then, which we need to look at. So what's it say? It says find an option that player B will never choose. Oh, so it's dominance again. Of course, it says at the top. So we're doing dominance again, and we're looking for something that player B will never choose. So we're just looking to see if 1 always beats the other. So 1 is lower than the 2. -2 is lower than... then the 3 is not. Okay, let's try this one. 2 equals... 1 is lower than the 2. Now look, this one is weakly dominated. So given the choice out of these two, now remember, for player B, we want the number to be as low as possible. Negative, ideally, because that means player B wins. But you can see, so here, on this one, -1 is better than 0. 1 is, well, effectively 1 loses 1 point here. Player B loses 1 point, but here they would lose 2 points, so that is better. And here they're equal, so it doesn't really matter which one is which one you do. So I would say that V is all for B. V is always better than W. So I'm going to say that W is dominated by V, player B. should never choose. Now, remember this. So the 2 would make B lose 2 points. Yeah, so you should never choose the W. I just wanted to make sure I got that the right round. What's it then say? It says, now find an option that player A should never choose. Okay, then. So we're basically now looking for exactly the same. Let me change my color of my pen so it stands out a little bit. So we're looking for down the rows now, and the numbers are for player A, so we want them to be as high as possible. So you can see the 2, and the 2 beats the 1, the 1 beats the -2, and that, yeah, that kind of works, doesn't it? So I think here, just get my head around this, so 1 wins against -2. 2 beats 1, yep, it does, and this is equal, but that's okay, that's weakly dominated. We've seen this word before. So basically we're saying then that, again, I'll just make sure I get this right around. I think U is dominated. I just realize it's not very good, is it? Here, I've got UVW and then UVX. I'm not sure that helps having it like that. We'll have the same letters. It'd be much better if they called them, PQR or something like this, but they've got those letters, so I'll stick with them. And it says UV and X, presumably some other choice, but I think here the U, in fact I've got that the wrong way around, it's V is dominated by U. Let's just check, clarify. 1 is higher than -2, 2 is higher than the 1, 2 is the same as the 2. So U wins, if you like, and therefore V is dominated. He should never play the V because V is rubbish. So what it's really saying is here, player A should play U and X, and player B, we said, should never choose W. So we've got U and V. And so we've got just a more straightforward table, effectively. U is still 1, and all I'm doing here now is copying that number. UV is 2. XU is 3. And XV is -1. So it looks like player A is going to win this game. You can see most of the points. But that is still the player B's best option, always. So look out for dominance. This is an important idea. Now, play safe strategies. We're going to look about this. And we have this thing called maximin and minimax. So it's slightly weird. Now, for a reduced game, it says you might have an opinion about which. The idea here is, what should you play? What would be your best option? So on that last game that we ended up with, now what would you play if you were player A? I quite like the look of, well, if A plays you, he wins both times. So you could argue, but if he plays X, he might win more, but he might lose. So you might have a theory, I want a chance. Or you might think, well, if you play safe, this way you're guaranteed to win something. Now, what would player B do? Player B loses 1, he loses -3. Remember, the positives are here for A. So here, player B, which one of these is better? He loses 2 here, but actually here he wins 1. So you've got which one would you play if you were playing this game? And this idea of which strategy is best is, as I say, is a play safe strategy, we call it. And the trick we're going to use is looking out for these row maximins and the column minimaxes. I've got an example to show you how we do it for you now. Let's click on. Come on. Here we are. So it says, find the play safe strategies for this zero-sum game. And this is how it would be presented probably in an exam. I'll give you the table. Here, as you can see, we've got player A and player B. Presumably there's no dominance because it's not asked us to talk about that. But we can just look at this idea now and try to work out which is the best option for both players. Now, the one thing I want you to be aware of is we try to draw a couple of extra rows and columns on this, and the rows and columns effectively look like this. So if I just show you what I mean, all I've done here is for the rows, I'm going to look for the minimum of each row, and we call this row min. For each row we have a row minimum, and likewise for each of these columns going down we have this col max, and you're going to have to learn and remember we look for col max and row mins. Now, what's my smallest number in my row? And you can see my smallest number is -2, like that. And my next row minimum number again is -2 again, same number. And my next one, my lowest number there is now -3. Now notice what I'm interested in. I'm interested in the maximum of these minimums. That's why we call it maxi-min. And my maximum, just be slightly careful with these, is -2. So this is the way, if you like, to get a better understanding of what each player should do. So let's now do the col maxes. The column with the maximum score is a 7. And here it is, just looking down there, is a 0. And the biggest one here is a 4, which is my minimum of my maximums. My mini-max is my 7. Now, you see, remember what you go for is the one that you definitely won't. You almost look for the least worst one. And what this basically tells me is that what would happen in the best circumstance, I suppose, because what this basically tells me is that really what we should be doing, if I was player A should probably now these -2s are the key. The -2 here, we can look at either of them. A should play, I'm just going to write this down, should play X or Y. Now we've got a choice effectively because there's 2 -2s. What about B? What should B play? Well, B's mini-max was 0. So that is in column Q. So B should play Q. Now this is basically what we'd say is a play safe strategy. So they're play safe strategies of what I've just found. A should play either X or Y, but B should play Q. Now it does say what would happen though if you knew player B was doing this. If you knew that player B was definitely going to play Q, now that might change your mind if you had that advanced information. So let's just look down at this. If you knew player B was going to play Q, you can see of your options now, you'll know you're either going to get nothing, you're going to lose 2, or you're going to lose 1. Well, obviously, player A should play X. Nah, this is subtly different, isn't it? This is, what if you have some advanced information? Now, these are the play safe strategies over here. Okay, that's all very, very well if the other person hasn't told you what they're going to do. But it might be if you play someone in a game regularly enough, you know they're always going to do the same thing. You know they're going to play in a certain way. And so if you knew that player B was going to play safe, as we've described it here, and playing safe is Q, then look at those numbers. Your best option as player A now is to play X. Now, let's do it the other way. What would happen if player B knew that A would play safe? All right, now A plays safe. Now it's slightly more complicated because he's got 2 options. He could play X or Y. Does it matter? So if he plays X, now we want the most negative answer. So X would mean player B, we want the most negative. I reckon that's P. Should play P. But what if he plays Y? Does it make any difference? I'm not sure is the answer. Y, we want the most negative answer. Well, now it's definitely Q. So it makes a difference because the -2s here are in different places. So probably P or X. P or Q, sorry. So you've got sort of subtly different answers depending on which one that player B has played, P or Q. So player B, yeah, exactly. That's what I was getting at. So where have I got my answers here? So the player safe string are X and Y and Q. That's what we said. And then, yeah, so the answers are there from the textbook anyway. I think broadly they've done what we've done. Now, one thing I would say to you is have a look at this. This is quite interesting. I won't play it now, but this is something called the prisoner's dilemma. And it's a bit in advance of what we've got, but it's also interesting as well. So you might want to have a look at that. I'll leave that there for you to have a look at. And now I want to talk about stable games, because that thing that we were just doing with row maxi-min and column mini-max is sometimes extended to ask you, is it a stable game? A stable game would be where both people, knowing what they now know the other person has played, would they have changed their mind as to what they played based on their play safe strategies? And you do this using the same trick, apart from you look at the row maxi-min and you look at the column mini-max. And if they're equal, you have a stable game. So that's what we're looking for. We are looking for two answers the same. So let's do a couple of examples. I'll just write these in here. So we've got the col max down here. And we've got the row min over here. So if I just do this on a couple of these, the minimum of this is 2. The minimum of this is -1. And the maximum of this, 2, that's 2. The maximum of this is 5. So my mini max, minimum of my maximums is 2, and that's that one. And my maxi min, my maximum, my minimums is maximum is 2. Now this therefore is a stable game because the two answers were the same. That's what we're looking for. Let's do B. So again, I'll do a row min over here, and I'll do a col max over here, and I'll do them now. So the minimum of my row here is -3. The minimum of my row here is 0, and I can quite easily see then that my maxi min, my best of my minimums, is 0. What about my col max? My biggest in this column is 2, is 5, and is 1. So my mini max, what is it? What's a minimum? Oh, it's 1. Ah, interesting. These are not equal. So this is what we call a non-stable game. Now look, I want you to practice those. I've actually got another 4 of these, so I'll show you these on the screen now. You've got these 2. I want you to do these. And then I've got these 2 as well. And I'll put up the answers so you can see them. But I do want you to have a go at these yourself. And once we've done this, we'll be able to do some questions in the booklet. Anyone who hasn't got the booklet, you might want to contact me actually, because I've got booklets for all of these stuff. So anyway, here's the answers, just so you know. And I'll see you for another video on game theory.